Good morning, everyone. Today we are going to discuss about simulating intermediate building blocks of a computer using logic gates in Logism. Next. Our team consists of 4 people. Myself, Harini Ana Perempuan Kanesan, Shasha Dayana binti Mat Sofri, Siti Nur Fatimah Zahra binti Abdul Rahman, and Nur Izzati binti Alwi. Next. Logism is a digital logic simulator used to build and test digital circuits such as gates in and ALUs. This project simulates 2 building blocks of a computer, 4-bit adder subtraction unit, and 2 to 4 decoder with enable.
The introduction to the circuit purpose for 2 to 4 decoder with enable is converting 2-bit input to 4 outputs used in memory block selection, instruction, decoding, and control unit. The input is A1, A0, and enable. For output, it is Y0, Y1, Y2, and Y3. This is the truth table for 2 to 4 decoder with enable. And this one is a screenshot of the Logism circuit for 2 to 4-bit decoder. Next, I will do the live simulator for the 2 to 4-bit decoder with enable. When enable is 0, the output will be 0. When enable is 1, you can enter the input for the A0 and A1. For example, when A0 is 1, the output for Y0 is 1, Y1 is 1, Y2 is 0, and Y3 is 1. Next, if the A0 is 1 and A1 is 1, the output will be Y0 will be 0, and Y1 will be 1, Y2 will be 0, and Y3 will be 1. If the A0 is 0 and A1 is 1, the output will be 0 for Y0, 0 for Y1, 1 for Y2, and 0 for Y3. That is for the simulator of the 2 to 4-bit decoder with enable.
Next will be the introduction to the circuit's purpose, 4-bit adder to subtract and subtractor unit. The first one used to perform both addition and subtraction on 2 4-bit binary numbers. Second one uses a control signal to choose between addition and subtraction. Number 3 is it's commonly used inside the arithmetic logic unit ALU of a CPU. This is the logic diagram for the truth table for 4-bit adder unit. And this is a logic diagram truth table for the 4-bit subtractor unit. And this is the screenshot of Logism circuit. Next, I will be demonstrating the simulation of the 4-bit adder and subtraction. So, when the mode control is 0, it will act as an addition. For example, when the A input is 0, 1, 1, 1 in decimal, which will be 7, and the B in binary 0, 0, 1, 0, and in decimal will be 2. It will sum up to 1, 0, 0, 1, and it will have an overflow of 1, and the carryout will be 0. And then, when the mode control is set to 1, the input of A is 0, 1, 1, 1, which is 7, and the input of B will be 0, 0, 1, 0, which is 2. So 7 minus 2, it will subtract 2. And the sum will be 0, 1, 0, 1. And the overflow will be 0 and the carryout will be 1. Which means that the circuit is functional and valid. Next.
Okay, for simulation design for 2 to 4 decoder with enable, first is input in circuit is A1, A0 optional inputs. Enable activate the circuit. Second is gates in circuit is we use NOT gate and AND gate. Third is control signals is enabled if 1, the circuit is activate, and if enable 0, the output will be 0.
For the 4-bit adder simulation design is input in circuit A and B optional inputs. Mode control is will be change mode to addition or subtraction ion. Gates in circuit is 4 XOR gates and 4 full adders. Control signal is if the mode control is 0, it will be addition mode. And if the mode control is 1, it will be in subtraction mode.
For circuit functionality, for 2 to 4 decoder with enable, first is when enable is 0, all of the output will be 0. When enable is 1, A1 is 0, is 0, 0, Y0 will be 1. A1 is 0, 0, 1, Y1 will be 1. A1 is 0, is 1, 0, Y2 will be 1. And the last is A1 is 0, 1, 1, Y3 will be 1.
For the circuit functionality of 4-bit adder subtraction unit, when the mode is 0, the sum will be A plus B. And for example, when the input A 0, 1, 1, 1, decimal 7, and B is 0, 0, 1, 0, which is decimal 2, the sum will be 1, 0, 0, 1, which is in decimal 9. The overflow will be 1 and the carry out will be 0. And then when the mode is 1, which is set to subtraction, the sum will be A minus B using 2 complements. The example will be the input A is 0, 1, 1, 1, in decimal will be 7, and the input B will be 0, 0, 1, 0, in decimal will be 2. The sum will be 0, 1, 0, 1, which will be 9 in decimal. The overflow will be 0 and the carryout will be 1. Next.
For application area CPU component, for 2 4 decoder with enable is 1. Use in memory address decoder, 2. Select block RAM, 3. Select register in register 5, and 4 is decoding instructions in the control unit.
Application in real CPU component for 4-bit adder subtraction unit is used in the ALU to perform addition and subtraction, update the program counter and calculate memory addresses, perform operations such as increment, decrement, and compare. Challenges we face while doing this project is arrange wiring of logic so that it does not overcome, understand XOR logic for 2's complement, and obtain the correct output of the decoder according to the truth table.
For summary is first, successfully built and simulated 2 important CPU components. Second, adder subtractor used in ALU for arithmetic operations.
The third one is decoder used in memory addressing and instruction decoding. The last one is logism is very helpful to visualize digital logic function. That's all from us. Thank you so much.